More than 45,000 times during the first 3 months of 2020, phones rang at poison control centers across the United States for the same reason: exposure to household cleaners and disinfectants. Among them was one chemical that has been part of everyday life for more than 2 centuries. It's bleach, also known as sodium hypochlorite. It's so inexpensive that most people never think about it. So common that almost no one questions it. Yet with just one small mistake, it can release toxic chlorine gas right inside your kitchen. So how did people turn nothing more than salt, water, and electricity into a chemical that is both familiar and potentially dangerous? To find the answer, we have to go back to 1785, to a small district on the banks of the Seine River in Paris called Javel. There, French chemist Claude-Louis Berthollet discovered that chlorine gas could bleach fabric much faster than the traditional methods used at the time. 4 years later, at a chemical workshop in the Javel district, Berthollet turned that discovery into a practical product. He bubbled chlorine gas through an alkaline solution to create a liquid that could whiten fabric in just a few hours instead of leaving it under the sun for months. He named it Eau de Javel, or Javel water, after the place where it was first made. But this original formula was too expensive for large-scale production. Around 1820, another French chemist and pharmacist, Antoine Labarraque, replaced it with a more affordable ingredient: sodium hydroxide. He also discovered that the solution could do more than bleach fabric. It could kill harmful bacteria as well. From that point on, Javel was no longer just a bleaching agent for the textile industry. It began making its way into hospitals, drinking water systems, and eventually into homes around the world. So how does this process actually work inside a modern factory? It all begins with one of the most ordinary materials imaginable: table salt. The salt is dissolved in water to produce a concentrated solution known as brine. This brine is then pumped into a membrane electrolysis system where 2 electrodes are separated by a special membrane. The membrane allows certain ions to pass through while preventing other substances from mixing. As an electric current flows through the system, chloride ions move toward one electrode, where they are oxidized to form chlorine gas. At the opposite electrode, water is split, producing hydrogen gas and sodium hydroxide, a strong alkaline compound that is also used in many household cleaning products. Thanks to the membrane, the chlorine gas and sodium hydroxide are collected separately on opposite sides of the cell. At this point, they have never come into contact with each other. But neither of them is bleach yet. They will meet one more time in a completely different stage of the process. And that reaction is what creates the familiar liquid found under the kitchen sinks of millions of homes around the world. In another part of the factory, the chlorine gas is transferred to a separate reaction tank, where a sodium hydroxide solution is already waiting. The chlorine gas is slowly bubbled into the solution. As soon as the 2 substances come into contact, a chemical reaction takes place almost instantly. Chlorine reacts with sodium hydroxide to produce sodium hypochlorite, the active ingredient in household bleach, along with salt and water. But this is also the most carefully controlled stage of the entire manufacturing process. If the temperature inside the reactor becomes too high, the reaction begins to take a different path. Instead of producing sodium hypochlorite, it forms larger amounts of sodium chlorate, a different compound that is not suitable for household bleach, and reduces the quality of the final product. To prevent this, the reactor is continuously cooled, keeping the solution at a low temperature, so the reaction proceeds in the right direction. The entire process takes place inside a sealed system. Even a small chlorine leak can pose a serious risk to workers, so every part of the system is tightly enclosed and continuously monitored for chlorine gas. Here's another surprising fact. The bottle of bleach under your kitchen sink is actually more than 90% water. The chemical responsible for its bleaching and disinfecting power makes up only a small fraction of the solution. Once the reaction is complete, the bleach is tested several times to verify its available chlorine concentration before being sent to different applications. Some is kept at a higher concentration for industrial use and water treatment, while the rest is diluted, bottled, and shipped to stores as the familiar household bleach found on supermarket shelves. But making bleach was only half the story. To become a product found in nearly every home, it also had to be inexpensive enough for large-scale production. Bleach had one major advantage from the very beginning. It was made from salt, water, and electricity. Three resources that were readily available almost everywhere. That opportunity caught the attention of a group of entrepreneurs in Oakland, California, in 1913. Each of them invested $100 to establish one of the first large-scale industrial bleach manufacturing companies in the United States. But the early years were far from easy. The product was sold only in 5-gallon containers, delivered by horse-drawn wagons, and supplied to breweries, dairy farms, and commercial laundries, places that needed large quantities of disinfectant. The company struggled financially and, at times, even had to borrow money from its own founders just to stay in business. The turning point came in 1916, when Annie Murray, the wife of one of the company's executives, suggested a simple but revolutionary idea: dilute the product, package it in smaller bottles, and sell it directly to housewives. Salespeople went door to door, dipping ink-stained cloth into the solution to demonstrate its cleaning power on the spot. For the first time, bleach made the journey from the factory into ordinary homes. The company was named Clorox, combining the words chlorine and sodium hydroxide. From an initial investment of just $500, Clorox has grown into a company generating more than $7.1 billion in annual revenue. Built on the same chemical principle that Claude Louis Berthollet first discovered in Paris back in 1785. Most of the time, bleach goes unnoticed. It quietly does its job in places most people never think about. At drinking water treatment plants, sodium hypochlorite, used at much higher concentrations than household bleach, is added to disinfect the water before it reaches the faucet in your kitchen. According to the World Health Organization, improvements in safe drinking water, sanitation, and hygiene could prevent up to 1.4 million deaths every year worldwide, and chlorine-based disinfectants are among the most important tools that make this possible. In hospitals, it is used to disinfect surfaces and medical equipment, helping prevent the spread of bacteria and viruses. Before wastewater is discharged into rivers or the ocean, it often goes through a disinfection stage that uses the same chemical. When COVID-19 spread around the world in 2020, this quiet role suddenly became highly visible. Many countries began spraying sodium hypochlorite in public spaces on a large scale. But later studies showed that the practice was largely ineffective outdoors, and the World Health Organization does not recommend spraying disinfectants in outdoor public spaces. The same solution, from the bottle under your kitchen sink to drinking water plants, hospitals, and wastewater treatment facilities around the world. Most of the time, we never notice it. Yet every single day, it quietly helps protect the health of billions of people. But the same qualities that make bleach so common and effective also come with a hidden downside. During the COVID-19 pandemic in early 2020, poison control centers saw a sharp rise in bleach-related incidents. Around the same time, a CDC survey found that 4% of adults reported drinking or gargling diluted cleaning solutions in an attempt to prevent the virus, although some researchers later questioned whether that figure may have been overstated because of the survey's wording. Not every accident involves drinking bleach. Many begin with misleading advice shared online. In one reported case, a woman soaked fresh vegetables in a mixture of bleach, vinegar, and hot water. Within minutes, she noticed a strong, irritating smell, had trouble breathing, and had to call emergency services. The danger comes from the chemistry itself. When bleach is mixed with acids like vinegar, it releases toxic chlorine gas. That is why nearly every bottle of household bleach carries the same warning. Never mix bleach with acids, ammonia, or other cleaning products unless specifically instructed by the manufacturer. More than 2 centuries after it was first created in a small workshop along the Seine River, bleach has made an extraordinary journey to become one of the most ordinary and most essential products in our daily lives. Every day, it helps disinfect drinking water for billions of people around the world. Yet, with just one simple mistake, the same chemical can turn an ordinary kitchen into a dangerous place. Perhaps that is the most important lesson of all. The inventions that benefit humanity the most are often the ones that become the most dangerous when they are misunderstood. In the end, safety does not depend on the chemical itself. It depends on how people choose to use it.